Hello students, let's welcome to our YouTube channel Physics for UG. So in this video, we shall discuss about Lloyd's single mirror. So Lloyd's single mirror is basically the approach of division of wavefront concept. So what is that? It is an arrangement consisting of a plane mirror to obtain two coherent sources of light to produce sustained interference. To produce a good interference, to produce a continuous interference, we use this Lloyd's single mirror. Look at the figure. Here S1 is the light source and M dash is a mirror. This one is the mirror and light is reflected from mirror first point and the mirror end point. So we get the reflected light at F as well as at D. Let's study from the parts. Point C is the point which lies symmetrically with respect to S1 and S2. This is S1 and this is S2, and point C lies symmetrically. Symmetrically means that is at the central line. From S1 to S2, at the central line there is a point that is C. This point is C, the other symmetrically. Since C lies outside the interference region, the zero order fringe is not visible. What is zero order fringe? Remember, in Young's experiment, at the screen at the center point there is a bright fringe. So this is the zero order. Zero order means at the central line the fringe is called zero order fringe, and after that it is first order, after that second order, third order, fourth order. So at the middle line this is the zero order. As the light is reflected from M dash towards F, so it will never fall upon C. So it will never get zero order. At the central line, at the symmetrical position S1 and S2, the symmetrical position is C. So at the point C, will never get a zero order fringe, and zero order fringe is not visible because C point will never get in ray of light upon C. So it can be seen by moving the screen to position A dash B dash so that it just touches the mirror. If the screen AB is the screen, this one is the screen AB. If the screen is moved towards A dash B dash, then what will happen? Then the point C will exactly touches that point mirror M dash. This point, the C will be here, that point C will be here. Okay, so if C will be here at A dash B dash position, then C will be a dark spot, because that will be a dark region. This region is a dark region because it will create a dark spot. Okay, it will be observed that the zero order fringe at M dash is dark instead of being bright as demanded by the theory of interference fringes, since at M dash the path difference is 0. At M dash the path difference will be 0. So which is contrary to Young-Tolstoy experiment, also in single slit experiment, because in single slit and double slit the central point is a bright always, and the alternate dark, both side dark, then bright, then dark, but the central is a bright always. But here, if the screen AB is shifted to A dash B dash, the point C will have a dark spot. This indicates that the beam which suffers reflection M dash undergoes a change in phase of pi radian. The phase change pi means the path difference lambda by 2. If pi radian phase change means one light ray towards right and one light ray towards left, then pi change means then there is a phase difference of pi. Pi means 180 degree, so they are cancelled out. So as a result, undergoes a change in phase of pi radian, so we get definitely dark, because already we have studied if lambda by 2 is multiplied with even number we get maxima. If lambda by 2 is multiplied with odd number we get minima. So for pi radian that will be lambda by 2 equivalent to lambda by 2 path difference. So lambda by 2 means there is multiplied 1 number 1, so 1 is odd number, so definitely we get minima at the point. So M dash will be a dark point. So what will the different cases for this Lloyd single mirror. Okay, in Lloyd's single mirror can be used to determine the wavelength of light. Let A is the height of source S1 above M1. So this point, this distance is A. From S1 to this line is A, and another line, this is also A. So this will be totally D equal to 2A. What is D? D is the distance between S1 and S2. What is capital D? Capital D is the distance of source S1 from AB. Source S1 to AB, this is distance D. Look at the figure here, this distance D. So what is fringe width? Fringe width beta is given by beta equal to lambda into capital D by small d. आज you want to watch the experiment. So lambda equal to beta into d small d by capital D. So beta into 2a by capital D. In this case, in Lloyd single mirror, that is d equal to how much? 2a. Okay, look at the figure. What happens? This S1 is a source of light which strikes the mirror at M and reflected towards the point D. Again, another point, there is a light S1 which strikes the mirror at M dash and reflected towards F. So definitely this part and these two parts, this is a shaded region and DF. Okay, now easily we can find, this is the Fresnel biprism, and using this Fresnel biprism we can find the value of beta. Beta is the fringe width, and by using the fringe width data we can calculate the wavelength lambda, where lambda is equal to beta into 2a by d. And remember, this Lloyd single mirror uses the division of wavefront concept. Thank you. If you like this video, then subscribe the channel, like the channel and share the video. Thank you.